Hello.
Hi
Hello.
guys. Good evening,
Hi.
Dr. Claire.
Good evening, doctor.
Good evening, doctor.
So,
So,
okay.
So,
Introduce myself.
yeah.
Let us
okay.
introduce ourselves. So, first of all, my name is Nurilia. My metric number is 199353.
So my name is Muhammad
Hi.
Ashraf. My matrix number is 198396.
My name is Siti Khadijah binti Marin Kuti. My metric number is 197541.
My name is Shafiq Ashraf Birahadi. My metric number 196689.
My name is Abdul Hamid Usman. My metric number is 195498.
Okay.
All right.
So,
So basically for our assignment, we are given a task to design a primer. So let's start on how we determine a good primer. Like how do we know whether it's a good primer or not?
Okay, so like when designing primer, there's few criteria, right, guys? We have GC content, GC%, and then we
primer
have
length,
the primer length,
EMTA,
yeah.
Optimum TM.
Yes.
TM.
Yeah.
What else?
and stability of the 5' and 3'.
Yeah.
Yeah.
Yeah. So for the length of primer, I found that the optimal length of primer should be around 16 to 30 base pair, right?
Yeah,
Yeah.
Yeah.
I found that too.
For
What about
GC
GC content?
content, I think based on the lecture note that I found, it's around 45% to 60%.
So, yeah.
Yeah.
Yeah, true.
For the TM, it
Okay,
is
for me.
around 52 until 60. I think.
Yeah.
The optimum one is 55.
Right.
Actually, for TM, I found two different infos. For the first one is 52 to 58, and the next
Oh.
one is 57 to 63. So
Oh.
But I guess
I
that depends
followed.
on our primer length, right? And our GC content itself.
Sorry?
Yes. The GC content and the length of the primer will actually
Affect
determine the
TM.
TM. Yes.
Yeah.
So should we discuss on the formulas on getting GC and TM, or do you want to discuss it later in our discussion and in our
Yeah,
results?
sure.
Yeah.
So based on what I found, we can actually calculate by ourselves. There's a calculation for the GC content and the TM content. To calculate the GC content is actually to calculate the number of G and Cs and then divide it with the primer sequence. After that, we times it with 100%. So after that, you will get the percentage of GC content.
Percentage of GC.
So what about TM? Do you guys know the formula for TM?
We did learn during principle of genetics, but I forgot.
I found it. So
Okay.
for TM, it's actually because we will divide it by the number of ATs and plus the number of GCs. So the formula will be 2 times the number of A and T nucleotides plus with 4 times the number of G and Cs. So after that, we will get our TM. And for TA, temperature of aniline, we will get TM, we minus it by 5, we will get the temperature of aniline. So that's the calculation that I found. So I think we should discuss. Welcome. So I think we should discuss on the 3 genes that we found for Texas brevifolia.
Texas, that means synthase.
Yes. So Hamid, can you start with your what primers did you find actually for Texas brevifolia?
Oh yeah, I used the BLAST format to find the gene you mentioned.
What gene?
I got. Sorry.
May I know what gene was it?
Taxadenine synthase.
Oh.
Yeah, and I found 2 primers actually, the forward primer and the reverse primer. Before that, I tried to adjust. Before that I had a problem actually because I used the default format, so I had to trace back to the nodes. And sorry.
Okay.
Okay.
Continue.
So all right. So I had to trace back to the nodes, and then I fixed the adjustments with the between 52 and the optimum. I made it 55 and the 60. Yeah. So then I blasted it with the accession number of U4H796, and then I got the two primers. I had about 10 choices actually, but then I chose the best one among them, the one that had the GC content between 45 to 60%, and the optimum temperature, as well as the TM. So for the forward primer, I got GGCGAACCAGAT 4 A's, then TG. That was for the forward primer. The GC content was 45%. I chose it because it fell within the range of the acceptable. And then for the reverse, what I got was ATGAT AA, TTGGCGGATA GTC. Also, it had a GC content of 45%. The remaining GC contents were 40%. Some was even 39%, but this was the best. And the product length was 146 nucleotides. This is for them. Yeah.
What was the product length again? The PCR
146. 146.
Okay.
Yeah.
So I think we should continue with Dija next, because mine is going to be a word. Dija, can you continue on your, what gene did you choose?
No,
So,
actually for first gene also I have found a primer. Can I share that too?
Yeah.
Sure.
So my primer was for the forward primer. It is ATG, GCT, CAG, CTC, TCAD. Okay, I'm just gonna read the details. For forward primer, the length is 16 base pair, and for the reverse primer, the length is 18 base pair. And then the best melting point I could get for both is forward primer 51.04, and for reverse is 46. I know it's quite low. And then for GC content, forward is 50, reverse is quite low, 33. And then the self-complementary is also quite high, 5 and 4. For the 5', 3' also for the reverse primer, it's 4. So I don't think it's a good primer.
Sorry
But
for interrupting.
Yeah.
I forgot to mention my primer length. It was 20. It was 20.
20, okay.
Okay. That was for the forward or reverse primer?
For the both.
Oh, both. Okay. So Dija, do you want to add on anything else?
And then for the primer, I didn't. Sorry.
Okay, continue.
What was it?
Do you want to
continue.
Yeah. Continue.
For my primer, I didn't start at the very beginning. I take from the 22nd
base
amino acid, I think. Yeah, base.
Okay.
Yeah, base. Sorry, amino acid.
So
I don't know if it's possible, since the doctor mentioned that we have to cover the whole sequence.
Oh yeah, the entire gene, right? But then again, we need to consider the perfect primer, because we learned that just now we discussed on the criteria, right? The GC content and such.
Yeah.
And then so we need to consider all those criteria, like because sometimes even if we take from the beginning and to the end, the self-complementary value might be high.
Yeah.
So like the strand might self-complement to each other if we don't find the perfect primer. So like
Yeah.
having the perfect primer, although we might have lesser product, but at least the product is stable, right? I mean that's what I understand from what we should do. Why we should do a perfect
True,
primer.
but mine also needs, I think, improvement because the GC content is quite low and the melting point as well for the reverse primer.
Oh yeah. Yeah, I guess most of us are also having problem at the reverse primer
Yeah.
because like finding the perfect one that matches to our forward primer. I mean like by GC content and such. Like it's like you need to study the nucleotide one by one, calculate one by one.
It's true.
So okay, so I think actually I did find
Ashraf, you want to share?
yeah, I actually didn't know if it's actually a solution on the GC content because I actually edited the primer a bit. So I'm going to share my screen. Can you guys
Alright,
see
sure.
the?
Yeah, we can.
Okay. So let's start with the because I was assigned to do 2 genes, which was Texas Proteolytic Synthesis DDC1, mRNA complete CDS, and also the Texas Bifolia DB80. So okay, so first what I did was actually because we know mRNA has polyaethyl, as we can see, and so as we know that an mRNA has polyaethyl, and we
Yeah.
cannot actually
Yeah.
put the reverse primer on the polyaethyl.
No.
So what I did was, if you press complete DNA sequence
CDS.
CDS, yes, on the glass, we can actually get the exact gene for the TDC1. So what I did actually, okay, so the highlighted one is after CDS.
Okay.
So what I did was actually based on this template, the CDS, I chose 16 nucleotides for the forward primer. 17 for the forward primer, and then I chose 18 for the reverse primer. So what happened was the circumference was actually quite high. So what happened was I didn't obtain the GC and TM that I want for the reverse primer, as you can see. For the forward primer, I obtained the optimal GC and TM, but the self-complementary was a bit not okay, was quite high. So what I did was actually I adjusted the reverse primer by adding, I don't know if it's, oh sorry, it's not there, but I added some additional nucleotides to the because additional nucleotides to the 5' of the primer, reverse primer. So after I did that, I got a new GC and a new TM, which was optimal to my reverse primer, which was 45%, and the new TM was 48 Celsius. So that's for the first sequence. For the second sequence, I think it's a bit more detailed, for you guys to understand. So DB80, actually the whole complete sequence is actually the gene. So from the template, I got this one is a reverse primer. So I highlighted it because it was already okay in the after I primer blast. But the sham complementary, I didn't check that one, so it was my mistake. But the TM and GC for the forward primer was okay as the length of 16 nucleotide. But the reverse primer was again not okay. So what I did, as seen here, that I added C and G at 5', and also I added GCG at the middle, and I removed the original C and A at the 3' end to get the optimum GC and optimum TM of 47% and 56 Celsius. So and also I I checked the 3' end of the primers, because in the lecture note is mentioned that in order to avoid GC clamp, we need to make sure that at the 3rd prime end there must not be like more than three GCs. So that's all from my part actually.
That's very nice, Achap. You actually explained that. So we can fix the primer by ourselves, right? That's what you just taught us just now, is it?
Yeah.
Oh,
Prof,
Mm-hmm.
so basically, you added the sequence before the primer from the sequence before the CDS, or you just randomly add.
I because at that time my primer was like lacking of C and Gs, right? Because the GC content is very low. So what I
Is it?
did,
So you
uh,
add GC.
I did GNC before the stop codon itself for the reverse
But
primer.
can we do that actually? Or
Based on what Dina told me, there's actually a part in our lecture note you can revise back. There are some types of primers because not all types of primers are actually aligned 100% with the template.
Yeah.
I
Some
know.
types of primers are considered primers, but actually there are five. The 3' end must be 100% aligned to the template. But the 5' end, I think it's better if I show you the lecture. I got. Wait. Do I got it here?
I think I understand like how we did during GE, right? Last time. The
Yes.
cross method thing.
Oh yeah.
Like
Cross
half je yang complementary, another half it's not really, it's for another strand, something like that.
Mm-mm.
I tak ingat. By the way, it's tinggal 10 minutes. So nanti I buat Zoom baru. Nanti I edit situ.
Okay, let's
Let's
proceed.
continue.
Okay, for the second gene, we have chosen then
DAPT.
BAPT. Apa?
DAPT.
DPAT.
Yeah, BAPT.
press the second.
That's the
Yes.
second gene, right?
Yes. I think
Alright.
Irina or Shafiq can continue for the third gene.
So
We
our
finished second.
third gene,
Mhm.
wait, I just do the introduction. Our third gene is the short name is DBT-NBT. The name is 3'N dibenzoyl taxol and benzoyl transferase mRNA.
Yeah.
Okay. So actually, since there are two people right doing this gene, me and Shafi, so I think we can both talk about our finding. I mean, like,
Okay.
I can talk about the primer that I found, and you can
Yeah.
talk about advice.
Okay.
I mean, basically, what I found, we use the same forward primer. Wait, I think we are using the same forward primer, but the thing is finding the reverse primer and making sure that they meet all our criteria is like a bit hard lah, a bit complicated. Sorry. So for mine, what I found, wait, let me open my data. For my part, although the GC content is same 50% for my forward and reverse primer, but the problem is at the self-complementary. So for the self-complementary, my self-complementary, one is 3 and the other one is 6. So 6 is a bit high, I think,
Yeah.
which is not good. Although my PCR product is 1000 plus nucleotide, it's a lot, but if we have a high self-complementary value, it might lead to dimer formation. It might lead to self-complementary between the sequence itself. So that's why I don't think I'm going with my primer. So like for Shafiq one, I think it's better, Shafiq.
Okay, for my primer, for the forward primer, I will just read ATG, GAG, AAGG, CAG, GCT, CATC. And the TM is 59. Okay. And the GC is 55. The self-complementary is 3 and self-3 complementary is 3 also. For the reverse primer, it is GG, AG, GT, CGT, GAA, TAG, GGG, TA. The TM is 57, GC 55, self-complementary 2, self-3 complementary 2. Okay. So the way I do it is by design my own primer, and using primer blast, I will just put the forward primer, then but not place the reverse primer, so it will design its own reverse primer. Yeah.
Oh, okay, that's very nice. At least when the result come out, you will have all the same forward primer, right? But then
Yeah.
it will show you different reverse primer and like
Different reverse
different
primer.
length. So for your chosen primer, what is the length of the product?
The length, product length is 427.
Okay, that's high. That's still high, yes.
So
You
actually,
forgot to mention the name of the gene.
Oh, the name of the gene is
The name is
DBT and BT.
DBT.
The accession number is AY 563629.1.
All right, thank you.
may I ask a question?
But
Yes.
What is the optimum length actually for the product length?
yeah, I think 400 is quite low.
Oh,
But I think
So
it depends on the gene actually.
Because
Yeah,
Yeah.
I mean like
one maximum.
most of it is 1,000 plus, right? That we have here.
We would want maximum, like we would want as much as the gene itself, right?
oh,
So,
Hmm.
but then again, if we don't form the perfect primer, then there might be like our product might not come out the way we want it, even though
Yeah.
we choose the primer at the beginning of the sequence until the end. But then we have to be able to make sure that our primer will be able to produce a good product.
But at that part actually, because if it's according to CDS, I agree on that part, because like in cases we cannot take from the polyethyl. But if you see the part like the translation for the protein, I'm having a dilemma over here where I don't know actually if one protein is missing, does it actually become the gene?
Sorry?
Oh yeah. In other words, like if we shorten the primer, right?
If you shorten the primer, some proteins will not
if
be
we don't take the
translated.
coding sequence.
So actually, if
Yeah, you're right. Also.
because I'm thinking a bit about that actually, because while I was like doing my primer design, there was a part where we can change the primers, but it translates the same protein, but different sequence. But I don't know if it's applicable in our case or not.
So does that mean that we can actually design our primer from A to Z until the end of our coding sequence? Design it first, and then, like you taught us just now, change the primer bit by bit to make sure that it's perfect.
I change it, but there's actually a way to change it, because I can't open the slide right now. I'm sorry. But in the lecture note, because what I did was I altered it to be a primer, but like in a condition that to also obtain the TM. Like I said, to adjust before because the 5' for the primers, for the restart for the forward primer will be the start codon, and the reverse primer will be the stop codon, right? So I just added a few nucleotides. So let's say if I'm lacking of G and Cs, I add some G and Cs at there. But I actually don't know what will it affect on the self-complementary of the primer.
Oh yeah, I understand because you changed the nucleotide, right?
Uh-uh.
But then, like you said also, just now you said you can change the nucleotide which can produce the same protein.
Yeah.
Yeah, that might make sense as well, but it means that we have to do it properly, right? We have to design it one by one and to make sure that, yeah, because protein can be coded by like three, right? Some proteins.
Yeah. But I'm actually looking at that because I don't know if it's applicable because for my case when I altered my own primer based on the template based on the primer glass, I found out that we cannot run that primer we cannot run the altered primer on primer glass because it's not in that template. But based on Dr.
Yeah,
Jeff's
true.
lecture note, what a friend taught me was actually that way is also applicable like that. The 5' part, the branch 5', and then
Still okay.
we add some nucleotides before the 5'.
Okay. Yeah,
So I
because
think
because by primer class it's computer based, right? But then if we perform PCR, then PCR machine is different, right?
yeah.
So they can actually detect our own primer, right?
So if I'm not mistaken, the first gene was TDC1, the second gene was DBAT, and the third gene I forgot the name.
DBT MBT.
DBT and DBT. Okay. So do you guys want to add anything for the conclusion as well?
I think all of us have to find better primers with better
properties.
I think we need to maybe refer back to maybe ask some people also on, because we already find our primers. We just maybe need a bit of adjusting a bit on the primers. And maybe
we can try Ashraf method on how like we can add.
Ashraf can explain his method.
Yeah, actually, I also learned it from a friend because I was having some difficulties because in my mind I thought that in my mind I thought that we need to obtain the optimum GC and DM while actually maintaining all the translation of the protein. So that's why I asked a friend.
Right, like if it would interfere with the protein production later because you change the nucleotide.
That's my fear also.
But then again, yeah.
But I think we can also ask maybe some of our friends also on maybe to perfect our primer, make a good primer. So
actually, I did ask a few group. Like some of them, they didn't even start from the very beginning. They just start from the the middle. Sorry.
Oh, they start from the middle.
From the starting of CDS or anywhere?
No, anywhere. Like where they think it's rich in GC content.
Okay, I understand. They basically just choose random primers from the top and the ending one, and then they just make sure that the primers are okay, right? Have good property.
And then the properties, some of the properties is not within the range, but it's not too far from the range.
Okay, I understand. Like just now, Shafiq one also like his one.
Yeah.
Like example, like the self-complementary is 2, which is okay, I guess. Still lower than most of what we got because some of us got 6, right? It's quite high. But I think we need to check again, like how high, how maximum should it be, like if it's really that bad. Maybe 6 is still okay, we don't know. I think we need to do a bit more reading on that.
Yeah.
6 is actually high. 3 to 4 is quite okay.
3 to 4. Okay.
Yeah, but
it should
be like
3 to 4. Like
I think the good one is 1, 0.
Okay.
So, Hamid, do you want to add anything for the conclusion also?
I think since we are from the same gene, You will teach me your method privately.
Yeah, because I think I need to also learn that, because that was I just learned it during this evening actually.
Okay.
Because I was just asking a friend, but I need to learn back on that method if it's properly correct or not. So we need to see later.
All right, sure. Shafi?
Shafi, you want to add
Okay.
anything?
Maybe if our primer is not reach the optimum or the best GC or TM, maybe we can try to add or delete some of the nucleotide to get the best primer.
All right.
Yeah, I agree.
I don't
Just
think
take
we
it
can
from the
delete
developer sequence itself. Either you add it or you minus one. One or two depend lah. Depend within the range of the PCR primer length. Dija?
Sorry, my internet connection was still. What did you say, Ilya?
Oh no,
We
I
change the
just agree
primer
with
according to the
Shafiq just now.
Shafi.
Oh, but I don't think we can delete the nucleotide.
No,
What do you
not
mean
No,
by
it's
delete.
that?
not
Like when you design the
on the
primer,
primer.
you can do between 18
Oh,
to
I see.
what that's why you
Ah,
do 18, you can do in
Okay,
between.
okay.
Not delete. Just
I understand.
not delete all.
It's between
Okay,
16
let's
to
talk
31.
about the report.
Okay, so report, I think, who wants to compile the report?
Me.
Okay, so we will compile it by Dija. So we should end our discussion because not to make it too lengthy also. So, so thank you everyone for participating in this discussion on our bioinformatics primer design practical or assignment. So
Welcome.
I think we'll see each other in the WhatsApp group for further questions and further information.
Okay.
Thank you guys.
All
Bye
right.
bye.
Thank you, everyone.
Okay,
See you.
thank you.
Thank you.
Bye.